Welcome all, welcome to KP classes. So today in this slide section we'll be having a discussion about geomorphology and introduction to geomorphology, a complete detail about the topics that we'll be discussing in geomorphology section. We'll also discuss a small topic in detail over here. So as you guys know, we KP classes are IIT and IIM graduates running this section, which where we provide geology related coachings for GATE, GSI, NET, CSIR, IIT JAM and all other competitive exams related to geology. So currently we are running GATE, NET and GSI offline online recorded lecture section, and also we are providing IIT JAM Geology lectures, live online classes for IIT JAM students, IIT JAM aspirants, MSc Geology entrance for the MSc Geology entrance examinations. Parallelly, we are giving a TNPSC. There is examination of TNPSC will be coming on August for combined geologist post, assistant geologist post. For that also, we are providing a recorded lecture course. So mock test of TNPSC will be released soon. So today let's go to today's section of geomorphology in detail. So when it comes to geomorphology for competitive exams related to geology, let's take NET CSIR examination of Earth-science. There geomorphology is a very important topic. Every year minimum 4 to 8 marks questions are asked from geomorphology. It's a must, even if like every year the minimum 4 to 8 mark questions will be asked from geomorphology. So it's a very important topic for next CSIR Earth-science paper. From in GATE, usually very comparatively easier questions are asked in geomorphology. Numerical and theoretical questions will be asked from geomorphology both in next CSIR and GATE paper. When it comes to GSI, combined Geoscientist examination, there the questions are usually tougher and much more detailed questions will be asked rather than like when you compare with GATE, much more tougher questions are asked in GSI paper from geomorphology section. Then in IIT JAM also comparatively direct questions, easy questions are asked from geomorphology. Match the following or kind of questions are asked from geomorphology. So let's discuss about the topics that we discuss over here when it comes to the different topics. So this is actually, geomorphology is a very huge topic. So if I combine all of them into 5 different points, these are the different topics. First one is the processes, weathering, uh, pedogenesis, mass movement, erosion, transportation and deposition processes we have to study in detail. Other than that, the next one is geomorphic processes and landforms, fluvial, glacial, aeolian, coastal and karst geomorphic processes, and the different landforms associated with each geomorphic process. So the most important geomorphic process is fluvial. For NET examination and for GSI examination, the most important geomorphic process and landforms associated with is fluvial. A detailed section of fluvial is very important for both NET CSIR Earth-science paper and also for GSI paper. This particular section, fluvial geomorphology, is very important. When it comes to GATE, they usually ask match the following. So, glacial, aeolian, coastal and karst topography, landforms are also, and definitions are important. Processes are not much required, but you should have an idea. Next CSIR also ask about aeolian landforms, especially the different types of dunes and the properties associated with that. The properties associated with the formation of different types of dunes are very important. The direction of wind for the formation of dune, the amount of sediment supply required for the formation of dune, etc. All these terms are very important when it comes to the aeolian landform. So if I would say fluvial and aeolian are the most important geomorphic processes and landforms associated with these two conditions are very important than the other geomorphic processes. Next one is river forms and processes coming under fluvial system. different types of river and the processes associated with that, stream flow, stage discharge relationship, what are the changes that is happening to a river in the downstream direction with an increase in the discharge, what are the changes happening, or with increase in the slope, what are the changes happening. So in a detailed manner you should have an idea about the entire stream flow and stage discharge relationships. Next one is landforms in relation to climate, rock type, structure and tectonics. Means how you take kind of structures are there, no? Like associated with the different types of landforms which are associated with different types of structures. If it is a parallel bedding region, or whether it is a inclined terrain, so in different set of tectonic alignment, different types of geomorphic landforms will be forming. So that's also an important part. You should have an idea about the different types of landforms associated with the horizontal bedded terrain or an inclined bedded terrain is also important. Next one is hydrographs and flood frequency analysis. Hydrographs, we over here we include hydrographs along with the geomorphology section. We don't include hydrographs in hydrogeology. Here in along with geomorphology we will be discussing hydrographs, because hydrographs mainly they ask questions related to drainage basin and how hydrograph variations are happening based on the morphological changes of a drainage basin, or based on the vegetation present in the drainage basin, slope of the drainage basin, etc. So because of that we define the hydrograph or flood frequency analysis is been done to over here along with the geomorphology section. So these are the different subjects that we discuss in geomorphology, or the topics that we discuss. May IIT JAM, for IIT JAM you may not read required these many topics related to geomorphology. Comparatively lesser topics are required. For example, we don't need river processes, stream flow, stage discharge relationships are not required, but the basic equations are required. Like you should have an idea about bifurcation ratio, what is discharge, uh, what is stream order, kind of terminology, what is the first order stream. These are the basic terminologies associated with river channels. So those terms are also are important for IIT JAM students also. So let's continue with a small section and a small topic related to geomorphology. And I'm going to explain about the river forms, and a single I'll take define different types of river channels, and we'll stick upon meandering channel in detail over here. So I hope you guys understood the uh, different topics that we are going to discuss and its importance. As I said, if I divide each of these topics based on the exam and their importance over here, the first chapter, processes, weathering, pedogenesis, mass movement and erosion, transportation, deposition. This is very important for IIT JAM examination, and sometimes they ask about from this section, they will do ask in GATE also in rarely, and in PSUs like state PSUs also they ask questions from this section. Next one is geomorphic processes and landforms, fluvial, glacial, aeolian, coastal and karst topography. This is important for all the competitive exams related to geology. For every examination, even if whether it is a PSU or UPSC examination or a GATE paper or any other IIT JAM or MSc entrances, this second chapter is a very important section. Next one is river forms, processes, stream flow, stage discharge relationship is important for GSI and NET CSIR paper. This is important for all exams. Then the fourth one, landforms in relationship to climate, rock type, structure and tectonics. This is important for GSI, GATE, NET paper. Then hydrographs and flood frequency analysis is mainly related to NCSIR and GATE. these two exams they ask about hydrographs and the flood frequency analysis. So I hope it's clear for everyone what are the major important topics associated with geomorphology and the importance of each topics in different competitive exams. So it's clear. I hope if you guys have any doubts related to the syllabus that we cover over here or topics that whether we cover a particular topic, anything you can comment down. We'll discuss it over here. I'll reply to you that whether we will be discussing that topic or not. So as you can see, we complete geomorphology will be covered in the five different chapters that I have mentioned over here. Complete geomorphology will be covered. And while I discuss the chapters, if a previous year PSU questions along with the net GATE and IIT JAM questions will be discussed in the section. So let's continue with a small topic in geomorphology. Not small topic. This is the most important chapter in geomorphology. So let's discuss about the alluvial channel. So when it comes to alluvial channel, there are two different types of alluvial channels are there. First one is not two, sorry. There are different types of classification. First type of classification is dividing them into braided channel, straight channel, meandering channel, and anastomosing channel based on their morphological property or based on their how they looks like or how they flow depending upon the sediment transportation, depending upon their slope, discharge relationships type of flow. We divided them into four: braided, straight, meandering, and anastomosing channel. There is also another set of classification where the channels can be classified into suspended load, bed load, and mixed load channel. When it comes to suspended load, a channel that has less than 3% of bed load in it. Bed load channel means more than 11% of the channel consists of bed load. Mixed load means 3 to 11 percentage of the bed load transportation is sediment transportation is happening as bed load, and that is called as mixed load channel. Width to depth ratio is less than 10 in suspended load channel, which is greater than 40 for bed load channel, and 10 in between 10 and 40 we will get in a mixed load channel. Sinicity is greater than 2 for suspended load channel. For bed load channel, it is less than 1.3. 1.3 to 2 is the sinicity of mixed load channel. For a gradient of suspended load should be gentle. It should be steeper for a braided channel. A moderate gradient defines a mixed load channel. So this is different types of classification of channel, how we discuss when the different types of channel classification. Sinicity and channel gradient is what defines the straight, meandering and braided channel actually. Sinicity and fluvial gradient. If the fluvial gradient is high, sinicity value will be low. So for a braided channel, the gradient is much higher, and for a meandering channel, gradient will be lesser. And same ways for a meandering channel, it usually is a suspended load type channel, and a braided channel is actually a bed load type channel. The sediment transportation will be usually in form of bed loads. So these are the basic terminologies associated with the top alluvial channel. So let's discuss about meandering channel in detail. When it comes to meandering channel, it is simply when the sinicity of channel is greater than 1.5, we call it as a meandering channel. What is sinicity? Sinicity means we are measuring the length of the channel, like from here to here of the channel. If I measure the length from along the channel measurement, if I take this much is the length between point A and point B. Whereas if I draw a straight line between A and B, that will be this much. So if I calculate the distance between these two situations, so this ratio between this straight line and the curve path is what is called as sinusity. For a meandering channel, sinusity value will be greater than 1.5. For a braided channel, it will be less than that, less than 1.5. It can go up to, like, it can be more than 2, like greater than 1.5 sinusity is what is defined by channel with greater than 1.5 sinusity is defined as braided channel. So over here you can see this, sorry, meandering channel. So over here you can see this is a meandering channel over here with a sinusity greater than, almost greater than 1.5. So let's discuss in detail about a meandering channel. When it comes to a meandering channel in detail, it has some peculiarities when it comes to the movement of water. The transportation of water is in a helical flow in meandering channel. That's an important point. Transportation in meandering channel is always in the form of a helical flow. Helical flow of water happens. So you look over here, water comes from here to this bank, then the water goes towards this bank, then again it moves towards this side. So it has a helical movement of water is happening inside the channel, and because of this helical movement of water, it has this meandering shape, and you can see that though the water moves towards this bank, in this way, you can see over here there is more erosion will be taking place in this particular bank because of water that is moving towards this bank over here. More erosion will take place in this side of the bank. Hence, deposition, the velocity of water at this particular bank is very less. Hence, this bank will be undergoing deposition of sediments. So, you look over here, here it will be deposition that is happening, and erosion will be taking place at this side of the bank will undergo undercutting, or further erosion will happen to this side of the bank. So I can say that if I draw a cross-sectional view of this particular channel over here along A dash, if I draw a cross-sectional view, it looks like this. A will at A dash over here, and this is A. A dash, it is deposition happened, hence it is shallower over here. Towards the side A, it is more high velocity water comes over here, hence more undercutting takes place at this particular side. So it will be much more deeper over here. Same goes with C dash over here. At C dash, it's shallower because of deposition happens, and C, it is deeper, and the water movement will be in this particular way. In between at this particular point of B, it's neither it's almost not a helical flow, it's almost water move. The deepest portion should be over here, but though there is a deposition takes place, deepest portion will be from the either side in the same way. Okay, so this is the peculiarity of a meandering channel. When it comes to a meandering channel, deposition happens at this particular side, which is the convex boundary. At the concave side, it is undercutting or erosion is what is prominent over here. So this particular deposition happening along the convex boundary of channel causes formation. So over here in this convex boundary side, it causes further deposition over here. So this is the mid channel region, inner bank region over here. This is the outer bank region. At the outer bank region, more and more erosion happen. At the inner bank region, more and more deposition happen. So in the inner bank region, mid channel region and outer bank region, you can see that the water level will be much higher over here. This is the water level higher at the outer bank region, because we know that's how water flow takes place. when water moves towards helical, it goes towards the outer bank region from one side, then again from one outer bank region to the other outer bank region it moves. From this is one outer bank region, from here it comes, and then from there to this outer bank region it moves. So water level at this particular bank it will be much higher than water level at the inner bank region. Okay, so this is about the water surface level in a meandering channel, and let's see about the deposition. So we have to study in detail about each of these terminologies that I discussed over here. So this is just a small description of meandering channel. So don't assume that this is a very less topic or like there is nothing much to discuss, but this is a very elaborate section is required. Very elaborate section is required for meandering channel. This is a very precise part of meandering section. Over here in this channel, you can see that this is a deposition that has happened. Almost looks like a cross bedded strata over here, and this is the present channel. This is the from this particular. This is the outer bank region over here, and this is the inner bank. So in the inner bank, when deposition keep on happening, outer bank undergo erosion. So whenever this deposition happen in the inner bank, deposition takes place at a particular direction. The sediment will dip towards the channel. Deposition of the sediment takes place towards dips towards the channel. Hence, this was the initial deposition that took place. Or over here in this figure, if I would say initially, this is the beginning of the channel. Now, in the current scenario, deposition will happen over here and erosion will take place at this particular situation. So, the current boundary with time, the channel will migrate in this particular direction. This mesh part got eroded, and here this mesh part got deposited. Again, next layer of sediment deposition happen over here with time, and here it will be eroded. So this part will be eroded. Here a new set of deposition has happened. So in this way, this deposition of sediment taking place in the inner bank of a meandering channel is called as point bars. They are called as point bars, and this point bar deposition takes place in this particular way, like it dips towards the channel, and along with the deposition of point bar in the inner bank region, at the outer bank more and more erosion takes place, and ultimately the channel is migrating towards this particular direction. Channel will be migrating from this side towards this side. So in a topographical view, the channel which is in this here at time t naught, channel is at this particular location. At time t1, channel will be completely migrated to, from this side it's more erosion happen, and then this side it's more deposition takes place. This is how this bank looks like. Here more erosion deposition happen over here, more erosion takes place over here. This is how the channel will look like after let it be after 20 years, sorry, after 100 years or after a 1 million year. This is how the channel will be shifting. This particular boundary A will be located over here because more erosion happened, whereas A dash part over here will now locate over here because of further deposition of point bars. Whereas over here more deposition of point bar happen, more erosion takes place at this particular boundary. So channel migration takes place. Look at the direction of channel migration. Channel migration is taking place in this particular direction. This is the direction where channel migration takes place. So this is the direction where channel migration takes place. Channel is migrating laterally. Okay, so lateral migration of channel happen towards this particular wherever the concave bank is there, towards that side channel migration is taking place. So while this channel migration takes place, there is lateral accretion of point bar also takes place. All these terminologies are very important. Lateral accretion, lateral aggradation, lateral migration, all these terminologies are associated with point bars. So this lateral accretion of channel, or sorry, lateral accretion of point bars, that is happening over here. Lateral accretion of point bar. This was the first point bar. Then the channel was like this. Then the second point bar deposition happened. Channel migrated. Third point bar, channel migrated. In this way, currently the channel, the migration has happened and it has been shifted to this particular location now. So presently in time t not at time t now, there is deposition happening over here and erosion takes place over here. So after some time the channel will look like this. Here this entire part will be eroded. Here a new set of point bar will be deposited. So you can see this lateral accretion of point bar that has happened in the meandering channel looks like a pseudo cross bedded situation, cross stratification. And this situation, cross stratifications formed because of lateral accretion of point bar is called as epsilon cross stratification. Epsilon cross stratification. This lateral accretion of point bar causes formation of epsilon cross stratification. So this epsilon cross stratification terminology is very important for all the competitive examination. Even for interviews they ask a lot about epsilon cross stratification. So epsilon cross stratification forms because of lateral accretion of point bars. Now there are more terminologies associated with the other landforms present in the meandering channel terrain. There is crevasse play which has a coarsening upward succession. There is natural levee formation, point bar deposits, floodplain deposition, back swamps, oxbow lakes. All these are different terminologies associated with the channel. You can see in detail about all the structures or all the landforms associated with meandering channel in this particular picture, which is a very important part. This entire definitions of each terminology. What is a chute bar? What is an oxbow lake? How a desiccation crag is associated with a meandering channel. Flood talweg. What is the term talweg defines? The crevasse play terminology is how crevasse play deposition has a coarsening upward succession. How does it have a coarsening upward succession? That is also a very important point. Then the natural levees and what are artificial levees, how do we start, why we started constructing levees across along the river beds, how it can help in preventing flood situations, etc. All these terms are very important. We'll discuss these entire topics in detail in our geomorphology classes. We do have both offline and online sections for GATE, GSI, the entrances, next CSIR classes. Recorded lectures are also available for other competitive exams. So currently we are having a TNPSC recorded lecture course is going on. So whatever details you require about our classes, topics related to any of these sections, you can contact us in the details given in the description box. Avail our courses by clicking on the link given there. Book details, fill the details for the trial sections, and subscribe our channel for another live section notifications and everything. We'll be conducting live sections related to geology competitive exams. More and more live sections will be conducting, more and more videos will be uploading related to different geology topics or competitive exams. So everything will be valuable for you. Any suggestions regarding any of the topics you require, the videos you require, you can comment down. We'll make videos the related to your geology with your as per your suggestion also. So thank you so much. My name is Ruku Raju. Signing off for today. We'll come up with another live section. Thank you.